Why is embedded firmware security crucial for microprocessors? Imagine a tiny brain inside your electronic device that controls everything from turning on your smartphone to managing a car's engine. That brain is a microprocessor. Now, think about what happens if someone sneaks into that brain and changes how it works. That's where embedded firmware security comes into play. Embedded firmware is the low-level software permanently stored in microprocessors that helps them start up and run hardware properly. It's like the instructions that tell the microprocessor how to behave. Because this firmware is so fundamental, protecting it is super important. If hackers manage to access or alter this firmware, they could take control of the device, steal sensitive data, or even cause physical damage. Microprocessors are used in many places like cars, medical devices, industrial machines, and smart home gadgets. These systems often handle sensitive information or perform critical tasks. If their firmware isn't secure, it's like leaving the front door wide open for cybercriminals. They could inject malicious code, disable safety features, or manipulate the device to do things it shouldn't. That's why ensuring firmware security is a top priority for electrical engineers. They need to design systems that can detect unauthorized changes and prevent hackers from gaining control. One key reason for this is system integrity. Firmware controls how the device starts up and functions. If someone changes it, they could make the device behave unpredictably or maliciously. Another reason is preventing unauthorized access. Secure firmware uses authentication methods, so only trusted users or systems can make changes. This stops hackers from exploiting vulnerabilities. Firmware security also defends against cyberattacks like code injection or buffer overflows. These are common ways hackers try to break into systems. Using encryption and secure boot processes helps protect against these threats. Many embedded systems support remote firmware updates, which are convenient but risky if not secured properly. Without proper safeguards, attackers could install malicious firmware during updates. Hardware security features like cryptographic modules and secure boot work together with firmware to create a layered defense. This makes it harder for hackers to succeed. Maintaining operational reliability is also essential. Fault-tolerant designs and abnormal condition detection help prevent accidental errors or deliberate attacks from disrupting the system. In real-world applications, firmware security is vital for devices that need to work safely and reliably. Think of a car's control unit or a medical device. If their firmware is compromised, it could lead to dangerous situations. Electrical engineers must follow strict coding standards, implement authentication and encryption, and use hardware security features. This way, they can protect these devices from threats and ensure they perform their functions safely over time. Protecting embedded firmware isn't just about keeping data safe. It's about keeping people safe and ensuring devices work as intended.